like a transformer. Transformations change things. You know, transformers go from like robots to semis and all that. Okay, we're not going to go quite that far. We're just going to take a geometric figure like a triangle or a pentagon or a hexagon, and we'll transform that. So we can either change its position. So we might move it from quadrant 1 on the graph down to quadrant 3. We might change the shape of it. Actually, we won't, but you can. And you can change the size, make it bigger or smaller. Okay? Transformation changes the position, shape, and size of a figure. When you have a transformation, the starting figure is called the pre-image, the original one. And then after the transformation, you get what's called an image. So if you look on your notes there, you should see 3 examples. It says pre-image, image, pre-image, image, pre-image, image. The pre-image is the thing you start with. The image is what you get afterwards. Transformations can be isometric. This word here, isometry, you can either say isometry or isometry. This just means that it's going to keep the pre-image and the image congruent. It's not going to change in size. An isometric transformation keeps the figures congruent. Right? There are 4 types of transformations. We have translations, which move the pre-image up, down, left, or right. When you were in middle school, they called this a slide, but now that we're in high school, we're going to call it a translation. Reflections, that's going to reflect the image over a line. In middle school, you called it a flip, so we're going to call it reflections. Then we have rotations, that turns the figure around a point or spins it around a point. And enlargements will either make the pre-image bigger or smaller than the image bigger or smaller than the pre-image. We're only doing 2 of them. We're only going to look at translations and reflections today and tomorrow. So those are the only 2 types of transformations that we're going to look at. So if you go back to that very first picture there, it asks first, do the transformations appear to be isometric or an isometry? That means the 2, the pre-image and the image, should be congruent to each other. So when you look at your 2 triangles there on part A, would you say that those are congruent? Are they the same size, Jordan C? Yeah, so then we would say that, yes, this is an isometry. And then it says to decide what type of transformation it is. It's either a translation or a reflection. It's a translation, it's slid right and down. Okay, the second one, your picture's a little different than mine when I put it back up here. Does your pre-image appear to be congruent to your image there on part B? Okay, if you think no, then write not in isometry. If you think yes, then write isometry. Your pictures are really goofy, so go with what your gut tells you on part B. If you think yes, then write yes. If you think no, then write no. And then you have to decide what type of transformation it is. Did they translate it? Did they slide the pre-image over? Or is it a reflection? Did they flip it over on itself? What do you think yours looks like? Yours looks more like a reflection. Mine looks more like a translation. So go based off of what you think yours looks like. And then C. Pre-image to image. Are those 2 images congruent to each other? Okay, so then we would say that this is an isometry. Bless you. Translation or reflection? Both. It's both. It reflects and then it translates up, or you could say it translates up and then reflects, but this is both a reflection and a translation. All right. Today, we're just going to look at and work with translations. So you should have this already typed out for you there halfway down. A translation, also known as a slide, is a transformation that maps all the points of a figure the same distance and in the same direction. So if I had a triangle and I wanted to translate it, I would have to make sure I map all three of the vertices the same distance in the same direction. So if on point C, I went up 4 and then right 5, I would have to make sure I go up 4 and right 5 for B, and up 4 and right 5 for A. If you don't do them all the same, then it's not really a translation. So they have to move same distance, same direction. Your movement will be up, down. Sideways is a combination of moving up and down and left and right there. A translation will always be congruent to the original one. Translations are always isometric. So you should not change the size of your image today when you're graphing. They will always be congruent images. Translations keep them congruent. Using your quadrilaterals there, you're going to answer those questions below it. These are just different ways to describe a translation, to word it. So quad ABCD, that's my pre-image. And then the other guy is my image. Do you see the little apostrophes after each letter? That you say prime. So this would be A prime, B prime, C prime, D prime. The prime is always the second, the resulting part of it. So this first blank, point A is taken to which point? What do you think? Other way around. A prime, there you go. Point A is taken to A prime. Okay, segment CD is taken to which segment? Good, C prime, D prime. Make sure you put a prime on both of them. Your point B maps to what? B prime, good, Frank. Instead of saying taken, you could say maps. They mean the same thing. Angle BCD maps to angle B prime. Yep. B prime, C prime, D prime. So taken to maps to, they mean the same thing. C prime is the image of C. Good. Kind of going backwards here. C prime is the result of C. A prime, B prime, C prime, D prime is the image of A, B, C, D. Your primes are your resulting image. Last one. Does the image of A, B, C, D appear to be isometric? Does it appear to be congruent to it? Yeah. This is a translation. We slid to the right and then up to go from the pre-image to the image. So different ways to describe a translation. The second one, we're actually going to map the translation. So that first one, we're going to take pentagon A, B, C, D, E and translate it to A prime, B prime, C prime, D prime, E prime. I've given you E prime. So what you want to do is figure out how far you went over and up from E to E prime, and then use that distance and direction for each of the other 4 points. So I had to go right 1, 2, 3, 4, 5, 6, 7, and then up 1. Went right 7 and up 1. So then you're going to do that same thing to the other 4 points that are there. Don't forget to label your points. Once you've found all the points, and then play connect the dots so that you can create your pentagon. They should look congruent to each other. Well, my pentagon's not even the same as yours, is it? Your B kind of tails up higher. They should be congruent to each other. Go ahead and try number 10 then. Did you guys move right 5 and down 3? All right. Questions on actually doing the translation on that part. Okay. Another way to write a translation is using function notation, which is right here, that's all typed out for you. X, y maps to x plus 9, y minus 4. So instead of giving you one of the prime points and having you count it, I could just give you this function notation. X plus 9, so on the x-axis, you're going to move in a positive direction, 9. The x-axis, horizontal or vertical? Horizontal. So if I'm going to move positive on a horizontal line, which direction am I moving? Right. So x plus 9 means that you're moving each point right 9. Y minus 4. Well, now you go to the y-axis, and a negative direction on the y-axis means which direction? Down, and then 4 means you're going to move each of them down 4. So I'd be able to go right 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then down 4. And that would be my B prime. And I could do it for all the other ones, and then they should line up. And I think I already did it for you, didn't I, on yours? Okay. So what we're going to do on the bottom two is practice writing the function notation. We should have two answers here. Describe the translation and then write it as a function. Describing it, the first part, just tells you to tell it to me in words. So from triangle ABC to A prime, B prime, C prime, we want to describe it in words. Do your X movements first. Did I have to move left or right to get to A prime? Right, okay. And then you just count how many you moved right from A to A prime. 2, 3, 4, 5, 6. So I went right 6. And then did I go up or down? Down. 1, 2, 3, 4, 5, 6, 7. You guys agree with me? Okay, so that's the describing part of it. And then to write it as a function, geometric function, this xy ordered pair stands for the original. So take the original xy and move it or map it or translate it. X plus 6, that's my right 6, and y minus 7. That's how you'd write it down 7. Okay, so describing it, tell it to me in words, function, then write it with your x and your y's. Go ahead and try the second one that's there. For your next one, triangle A, your pre-image or whatever, triangle ABC is down in quadrant 4, and you have to count up to quadrant 2. Make sure you check that you're going to the primes. So I know I have to go left from 4 to negative 6. So I went left 10. And then I had to go up from negative 4 to positive 3, up 7. You guys agree? So then when you go to do it as a function, take your original xy and map it x minus 10, y plus 7. Kaden. If you can describe it that way, but did you have this written correctly then? Yeah, that's fine. If you wrote up 7, left 10. Yeah, that's okay. Yeah. Questions on describing it using function notation? Okay, flip it over. You're going to translate it now using function notation. So this is actually making sure you understand what it means, x plus 2, y minus 3. X plus 2, well, positive means either go up or right. Which way are we going to go? Right, good. Y minus 3 then, you're going to go down 3. So take each point, A, B, and C, and map it right 2, down 3, then name it A prime, B prime, C prime. And then don't forget to connect your dots to make the actual figure. They should be congruent to each other. Your C prime should be on your x-axis, and then the rest of it's all in quadrant 2. Are you good on reading it from your from your geometric function? Okay, let's skip 13 and let's go down to 14. Using the rule x plus 7, y minus 1, find the translation of the image triangle LMN, and then graph L prime, M prime, N prime. So do the same thing we just did on number 12. X plus 7 should mean you're moving right 7. Y minus 1, then you're going to move them all down 1. So then 1, 2, 3, 4, 5, 6, 7. Here's N prime. L prime. M prime. Don't forget to label your points and double check that they look congruent to each other. Questions on translations? Cool. All right.